So the screen is visible.
Yes, sir.
Thank you very much. Okay. So continuing from the last lecture, that is open loop and closed loop control systems. So we have seen that the difference between both the system is the feedback system which is there. Okay. So now for the feedback system, to implement the feedback and to make the required changes, there is a requirement of a comparison element. Okay, so comparison element basically compares the difference in the measured value and the input value, and the required changes are made accordingly. Okay, so that is why for a feedback system or a closed loop system, a feedback system as well as a comparison system is a must. Okay, yes, understood till this point? ये कल तक ये समझ आ गया था सभी को?
Yes, sir.
Okay, okay, thank you. Then next is the basic elements of a closed loop control system. Okay, so what are the basic elements? If you see now, if we just elaborate the whole of the control system into number of parts, and if we split them, then we have further parts or units which are there in a control system. Okay, it is applicable to the open loop control system also, and it is applicable to the closed loop control system also. अगर open loop की बात करें यहाँ पे, तो ये element और ये element आपका missing होगा, but these three elements are or units are still present in a open loop control system. Okay, is it clear? Okay.
Yes, sir.
Okay.
Yes,
Okay.
sir.
So what is there that you have given a reference value? So we will start with the reference value, and that reference value will be, firstly, it will pass through the comparison element, which is a comparator. It is a type of a comparator. Just a second. Okay. Comparator. Okay. So somewhat. It may not be clear, but one of the common example of a comparison unit is a comparator. So reference value which passes through the comparator and it goes to the control unit for the first time. Error signal आपका feedback के बाद आएगा. So initially you are giving a reference value to the control unit, which is further what the control unit is doing. It is controlling the value and giving some output to the correction unit. Then that correction is implemented in the correction unit and is further करेक्शन यूनिट में जो करेक्शन आपको जितने अमाउंट ऑफ करेक्शन करनी है उसका सिग्नल मिलेगा, एंड द फाइनली द प्रोसेस विल बी करेक्टेड. Okay, so we will see how it is done by considering various examples, but firstly we need to understand what all these parts are there for. And when the process has been implemented, you will get a controlled value, and again that value will be read by the measuring device, and that measured value will be sent to the comparison unit. And if there is some difference or whatever error is occurring, that error signal is again sent to the control unit. Control unit will decide what to do, and then the correction unit will implement that change and send it to the process. This is how the cycle goes on. So from the reference value you have a comparison unit, then a control unit. So control unit का हमने देखा था तीन. What are the three functions of a control unit? either to control a value or to decide for a sequence of operations, or to decide for either a function should occur or not. So three main functions are there for a control unit: either to control a value, or to make a sequence of operations, or to decide whether an event will occur or not. So in तीनों में से जो भी होगा applicable इस system के लिए, that will be implemented through the control unit, and whatever the value has been coming from the control unit will be sent to the correction unit and then to the process. Okay, so we will see one by one what are the various elements and what are their uses. So comparison element, it compares the required value with the, or the reference value with the measured value. Okay, reference value minus measured value will give you the error signal. So if this is the reference value and this is the measured value, so the difference between this and this is the error signal which is there. Control element, this decides, so यहाँ पे हमारा decision होना है whether to decide to do something or not to do something. This decides what action to be taken when it receives the error signal. ठीक है, तो यहाँ पे एक error signal generate होगा, यहाँ पे decision, this is a decision point. Then correction element, it produces a change in the process to correct or change the controlled condition. Okay, so this will produce a signal for the process. This will produce a signal for the process for how much value. So this will give you a digital form value. So here it will take a decision and this will generate a value. Generate a value which will be sent to the process. So process will be controlled finally. Okay. Then the measurement element, which is the feedback element. Measurement element produces a signal related to the controlled variable condition. अब हमने जो value को control किया है error के बाद, उस value को it will measure and inform the comparison element. Okay. So these are the 5 basic elements of a closed loop control system: a comparison element, a control element, a correction element, a process element, and a measurement element. Okay. Now, if we see these examples, now we will decide that what actually is occurring as these 5 units in each case. Okay. So firstly, heating of a room, which is a closed loop system, and this room heating may be through a switch, through electricity, or through a manually by the human beings also. Okay, manually by human beings also if they are getting some signal, or it is if we implement it through a controlled electronic system, that there also this system will work accordingly. Okay. Now, if you see the input signal is the what is the required temperature, as we have seen yesterday also, the required temperature is our input value, and this input value is given firstly going to the controller through the comparison element. The controller is here, you can see what are the various units which are there. Okay, the controller is the controller. It can be a manual rotary controller, or it could be a digital controller through a switch, through a remote control. So if we see today's ACs or heaters, they are controlled through a remote control, then controller will be the remote control of the system. And then we have this switch. Switch is the, what was the second unit after the control unit? The correction unit. So correction unit is the switch, either to turn on the switch or to turn off the switch. So controller will decide either to turn on the switch or off the switch. So if the switch is turned on, it will get a signal for the electric power, and the heater will turn on. Heater will turn on, and the required temperature will be to the room will be given as the output. And whatever the temperature is there, that will be measured, and the signal is again sent back to the comparison element, and till the required temperature has been reached, there is again some digital form of signal is given to the controller at continuous rate. ठीक है, कुछ ना कुछ सिग्नल जाता रहेगा जब तक ये मेजरिंग डिवाइस आपका जो रिक्वायर्ड टेम्परेचर यहाँ पे आपने इनपुट दिया था वो रीच नहीं करता. So it will keep on continuously measuring that and giving a signal to the comparison element, and a error signal, that is the difference in input and output temperature is there. This system will keep on working. Once that error becomes zero, the system will shut down. The system will shut down. So here you can see this whole part is a part of the thermostat element in actual heating system. तो ये सारे का सारा जो सिस्टम होता है हीटर के साथ थर्मोस्टेट लगा होता है जो, it is integrated in that thermostat itself. The controller, okay, the switch as well as the comparison element. So all three are integrated in the thermostatic element of the heating system. Okay, here you can see the controlled variable is the room temperature. The reference value is the required temperature. The comparison element is the person comparing the measure value and the required value of the temperature if it is a manual system. The error signal is the difference between the measured and the required temperatures. And the control unit is here is the person who is sensing the change in temperature. So control unit is the person itself. The correction unit is the switch, and the process is the heater, which is giving the heat, and the measuring device is a thermometer. Okay, so this is a manual system. How this control system can be implemented in the manual system also, that is written over here. Another example is automatic control of water level. So water is getting filled in some device, and once the water reaches in the tank to a certain level, then the water supply should cut off. That is another example of an automatic control of or closed loop control system, that is automatic control of water level. Here, what is the controlled variable? We need to control the water level. So our controlled variable is the water level in the tank. What is the reference value? Whatever initial setting we have done for the float and the lever position, that is our reference value. तो हमने जिस पोजीशन पे टॉप पे फ्लोट और लीवर की पोजीशन दी हुई है, that is our reference value. What is the comparison element? The lever will decide whether it has reached or not, so it will keep on comparing the values. Okay, error signal will be the difference in the lever value and the actual level of the water. Okay, what is the control unit? The pivoted lever. जो आपका pivoted lever है, that is now the control unit which will either switch on the water supply or switch off the water supply. So you see, the जो आपका lever है, that means the floating lever is actually the comparison unit also, but wherever the joint of the lever is there, which pivoted joint is there, where the tank water supply will turn off, so it will act as a switch only. So that is a control unit. So lever के साथ end में एक आपका switch लगा हुआ है, या आपका एक valve है इस केस में, that is the pivoted lever valve, which will actually turn off when the level has reached to a certain level. Okay, the correction unit is the flap opening or closing the water supply. तो कंट्रोल यूनिट एक्चुअल में किसको करेक्शन दे रहा है, सिग्नल किसको दे रहा है? सो कंट्रोल यूनिट का मतलब क्या होता है? इट विल गिव अ सिग्नल. ओके, and the correction unit will actually implement that signal by opening and closing the flap of the valve. And what is the process? The water level in the tank is the process. And what is the measuring device? The floating ball, and lever is the measuring device in this case. So you can have number of examples which you can see, and you can compare those with the comparison element, with the control unit, with the correction unit, and you can decide for each and every process. Okay. So the way we have done it for the manual heating of the room, we can implement that part with the automatic system of the heating of a room or cooling of a room also. Okay. So if we see, yes, Vibhor, are you there? Vibhor,
Yes, sir.
okay. If we see that, if we want to go for the air conditioning unit which is there in the rooms which we are using now, if you compare
Yes.
these elements with that air conditioning unit, then how can you decide that which unit is which one? Just give me one. What will be the feedback system in that case? फीडबैक सिस्टम आपका अगर बात करें एक रूम एसी में, तो क्या होगा?
सर टेम्परेचर सेंसर्स होंगे उसके.
Temperature sensor. And which type of temperature sensor is used in home air conditioners?
पता नहीं सर.
Okay. सानिध्य.
सर एसी वाला टेम्परेचर सेंसर का तो नहीं पता, पर सर हमने DST 11 सेंसर पढ़ा था टेम्परेचर का, उसमें कैपेसिटेंस बेस्ड था सर वो.
Capacitance based. ठीक है.
Yes.
Okay. Then what will be the comparison unit in that case? Comparison unit क्या होगा उसमें?
Sir,
Who is comparing the value?
सर वो तो कंट्रोलर ही होगा सर.
That is a part of the controller itself, है ना? जैसे इसमें देखिए आप
Yes.
thermostat लगा होता है, there is thermostat placed in front of the room air conditioners also. So the thermostat in that case will have the control comparison as well as the और कौन सा एलिमेंट होता है? करेक्शन यूनिट इंटीग्रेटेड इन दी वन इनटू अ सिंगल सिस्टम, है ना? वो एक आपका माइक्रो कंट्रोलर ही आज की डेट में माइक्रो कंट्रोलर जो यूज होता है, दैट इज एक्चुअली डूइंग ऑल द कैलकुलेशंस. So if you see in the room air conditioners also, a thermostat is there which is measuring the temperature, and it is directly integrated to a chip which is the microcontroller. So that chip will decide whether to turn on the AC or turn off the motor of the AC at a given point of time, है ना? So the system has become very integrated, or very you can say small in nature, that everything is integrated into a single system. Okay, very large scale integration is happening, and your overall system has been integrated into a single system, that is the microcontroller. So microcontroller के आगे सामने ही एक थर्मल सेंसर लग जाता है, उसमें से ही आपको कंट्रोल यूनिट कंट्रोलर, उसका माइक्रो कंट्रोलर का कंट्रोलर तो लगा ही हुआ है, एंड डायरेक्टली इट विल connect it with the switch that will turn on and off the supply. Okay. Yes, is it clear or not? So is it clear or not?
Yes, sir.
Okay. So you can, what you can do is you can just look for various type of control units and comparison units as well as correction units which are there in the microcontroller and how it controls it. You can look for various types in on the internet. ठीक है, आपको बहुत डाटा मिल जाएगा उसमें. You can just go through it and that will be more clear to you. Okay. Yes. So for any other further discussion you want to do on this topic, or we can move further. यहाँ तक clear है?
Yes,
Yes,
sir.
sir. Clear.
Yes, sir.
Okay. Now next is analog and digital control systems. Okay. So what is the difference between an analog and a digital control system? So digital version of any signal is always in the form of 0 and 1 or on and off condition. So you can have number of signals in a given system where the combination of 0, 1 and 0, 1 will decide what analog system or sorry digital signal is stored in it. So a simple example over here is shown, like if this this is a graph between signal, the amplitude of the signal and time of the signal. Okay, so this is the analog form. This is the analog form of the signal. And this is the digital version. So as you can see that here what is happening, if suppose 7 volt, so the signal over here is 7 volt at this point, and this 7 volt signal is the maximum voltage signal which is achievable for this particular graph, and that signal is dropping as the time advances, and at this point the signal becomes 0 volt. So for showing it in the digital form, what we need to do is we need to convert it to analog to digital form. Analog to digital form. So why we require the signal in digital form? Because the electronic parts, that is the microcontroller as well as the control unit, they work very easily on the digital form of signals. So they are programmed in such a way that they are able to understand the data in the digital form. Okay. So whatever is visible to us or whatever temperature we are sensing or giving to a system, when they are processed in the controller or the microcontroller, they first need to be converted into the digital form. And further, when this signal from the digital form is given out, that is for again in the digital form, which needs to be again converted to the analog form. तो example है, जैसे आप air conditioner की बात कर रहे थे हम. So you have, if you have set the temperature at 22 degrees Celsius, so the microcontroller will not recognize any value 22. So it will recognize 22 as some other type of combination of digital form, such that that data needs to be converted into that form only, है ना? Again, when it gives the signal out, then again that will be in the form of digital form, okay, but that will not be recognized or easily understood by humans, so it again needs to be converted from digital to analog form. ठीक है? So that means there is always a gap between understanding of a language between computer and humans. So humans generally recognize analog form of data, whereas computers recognize the digital form of a data. So we need to convert that digital form into analog form, then only the computer will understand it. And when whatever computer output is there, that again needs to be converted into analog form for easy understanding of the humans. Okay, clear? So here you can
Yes,
see
sir.
that if suppose there is a program which is there, so it has made this type of signal that 1, 2, 3, 4. Let this be a 5-bit system. Although there is no 5-bit system, but we will take an example. So this graph will show that 7 volt of analog system is given by this type of signal. तो इसका अगर मैं इसको मैं बॉक्स में डिजिटल फॉर्म में लिखूं इसको, so what will be the digital form of this signal? अगर यहाँ पे सिग्नल 1 है तो 1 0 1 0 1. So this type of combination of 1 0 1 0 1 will be equivalent to 7 volt as has been programmed for this type of system, है ना? तो यहाँ पे भी although it is a little bit less than 7 volt, but it hasn't reached 6 value. ठीक है? तो यहाँ पे suppose इसकी let this value it ends at somewhere over here, but actually 6 is over here. So these lines may be a little bit up and down. They are not, I'm completely straight lines, but we just are trying to understand it. Okay, so digital system works like this. So you cannot have any 6.7 value over here, so it will round off it to 7 volt. So again produce the same signal. तो यहाँ पे हो सकता है कि इसकी value suppose it has reduced a little bit and it has reached suppose 5.8, the average value. So it will round it off to 6. So producing 6, it is giving you the signal 1 0 1 0 0 like this. Okay, so this type of signal is it. So 1 is यहाँ पे ये जो है ये 1 है, यहाँ पे अगर कुछ भी नहीं है तो ये 0 है, यहाँ पे अगर फिर से आपका ग्राफ में एक्सटेंशन है तो it is 1 and over here there is no extension, so ये 0 and 0. So lastly ये हो जाएगा 1 0 0 0 0. So that will be equal to 4 watt. ठीक है, an average value. So you are seeing that the digital system actually will work on round off values or whole number values. It will not take any fractional values. So it completely rounds off the value and accordingly convert it into digital form, which will be understood by the controller. Okay. So यहाँ पे आपको एक और चीज समझनी जरूरी है कि a microcontroller having a bit of information. Normally we are using 32-bit or 64-bit of microcontrollers these days. But simply in previous generation systems, we used to have 8-bit systems also, which was able to make these much of information, digital information combinations, 2 raised to power 8. तो एक 8-bit system जो previous generations में use होता था, in a digital control system that was able to store how many distinct values? 2 raised to power 8. Like over here I have shown a 5-bit system. ऐसे ही अगर आपका 8-bit system होगा तो it will have like these 8 partitions. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so each box or unit or a bit was able to store 2 values, either 1 or 0. So इसमें भी 2 values, इसमें भी 2 values, इसमें भी 2 values and so on. So इससे जो combination बनेंगे, that will be 2 raised to power 8 combinations could be made. So this is how the digital system stores the value. तो कहने का मतलब है एक जो 8-bit system है वो आपकी 2 raised to power 8 whatever the value comes out to be, I think it is 256. This much amount of combinational values it could store. Now 64-bit system जो आजकल यूज हो रहे हैं 2 raised to power 64, it could store this much amount of values. So very large values it can store. So it will have more combinations. Therefore, you are able to store some fractional values for which you have different digital forms already defined to the system. Okay. So this is what is happening. Okay. So just give me a second. Okay. I will be back in 1 or 2 minutes. Just give me a second. Okay, sorry for the interruption. So everybody is here. Agam Prabhu.
Yes, sir.
So I
Yes, sir.
Yes, sir.
think somebody has left the meeting. So previously also 6 students were there, na? Baljit or Balraj. I don't remember the name. Balraj? Yes, Prabjot, what is the name of the student? Balraj or Baljit?
Balraj, sir.
Balraj, hai na? Balraj hasn't joined today's lecture also. He was not present yesterday also. So some problem with him, or he is not joining any of the lectures, or just this lecture?
Sir, I don't know.
Okay, okay, no problem. Just see for another 1 or 2 days, then otherwise I'll talk to him. No problem.
Okay, sir.
Okay, okay. So coming back to the digital and analog form of signals. So I hope you have already learned the conversion of analog to digital form of signals in some previous subject. Have you already learned it or not? The conversion of analog form of signal to digital form. Was it covered?
Yes, sir, it
in-
was discussed.
It was discussed in which subject? Mechatronics?
Sir, mechatronics subject.
Yes, sir.
Okay, okay, okay then. Okay then. We'll just skip this also. I hope this is understood to each one of you. So whatever things you are doing for twice, that should be very much clear to you. Okay. So this is again simply showing the basic elements of a digital control system. Okay. So what are the basic elements of a digital control system? So here everything else remains same. Instead of the control unit, if you see this control system, this is a closed loop control system. So the correction unit, measuring device, process, reference value, everything remains the same, but only difference is in the control unit. Now we have got the digital controller ke saath, we have attached DAC, that is digital to analog converter, and ADC, that is analog to digital control converter over here. Okay. Is it clear? So analog to digital converter
Yes,
is
sir.
converting the digital signal into analog form, which is read by the comparison unit. And again, from the digital controller, you are getting the signal in the digital form. So that again needs to be converted from digital to analog form. That is the fed to the correction unit. So this whole system over here, it is working on digital information. Further, all these systems are working on analog information. Okay. So that is why these are basically part of the microcontroller. So आपके microcontroller का क्या integrated part है? An ADC, that is analog to digital converter. So measuring device giving the value in analog form, which get converted to digital form and fed to the comparison element first, then to the digital controller, and then that digital controller gives the signal in digital form, which is then again converted to analog form from the DAC. So these are the part of the microcontroller. Okay. So everything else, that is this part, this part, this part, as well as this part also, it remains the same for as of the closed loop control system. ठीक है. तो इसमें जब हमने closed loop control system को digital form में दिखाना है, तो हम इसमें कंट्रोलर के बाद DAC ऐड कर देंगे और कंट्रोल एलिमेंट के पहले ADC ऐड कर देंगे, and we will show it as a complete part of the microcontroller or an integrated part of the microcontroller. Okay, so if it is asked that what are the various components of the microcontroller in a digital control system, so you will say that ADC, DAC, digital controller, and comparison element. All these are 4 parts of the microcontroller. ठीक है. तो अब क्या हुआ, हमने एक सिंपल सिस्टम बना के देखा पहले, सिंपल सिस्टम को फिर थोड़ा तोड़ के हमने पहले तो उसमें 3 डिफरेंट सिस्टम्स पढ़े, measuring system, modeling system, or dual system. I don't remember what the name. Just a second. Connected system, sorry. Modeling, measurement and connected system. So we started with the mechatronic system and we firstly converted everything to a simple system. तो सिंपल सिस्टम में भी जैसा रिलेशन होगा उसके हिसाब से उसको आप 3 डिफरेंट सिस्टम में डिवाइड कर सकते हैं, मॉडलिंग, मेजरमेंट एंड कनेक्टेड सिस्टम. Then we tried to elaborate it and we started with the control system, how control system is utilized in the mechatronic system. So from there we studied the open loop and closed loop control system, and we saw that open loop and closed loop were differentiated through the use of a feedback system. Then further, again we concentrated on the closed loop control system and learned 5 different elements which are there as a part of the closed loop control system. Then in a closed loop control system, further we studied the digital form of a closed loop control system, which is nowadays used vastly. So you have all the applications related to a closed loop control system having a digital control. So that digital control is not just the microcontroller which we are talking of, and for that microcontroller, the control system is further having an integration of DAC and ADC with it. Okay, so whole of it becomes the microcontroller. Okay, so this is how we moved in this chapter, that starting with the mechatronics part, we learned the simple system, and then we learned the control system which are actually controlling this simple system if we elaborate that simple system. And in that closed loop control system, we further studied the digital control system and its parts. Okay, is it clear? Yes, is it clear or not?
Yes, sir.
Yes, sir.
Okay, so lastly we have another control, that is the sequential control, which is there. Sorry. So sequential control, we have any operation which is going in sequence. So this is the part of the control system only, that we can control the value of a particular object, or we can control the sequence of the events which are occurring. So part of the control system only. So another application of a control system is the sequential control. Okay, this is how it is related. So taking again an example of washing machine, which is giving number of outputs, and these outputs are in series. They are independent signals which are fed to the control unit, and the control unit are deciding for each and every individual signal which is coming out. And additional parts which are there in a sequential control is the clock and the program of instructions. That is the additional part which is there. So program of instruction was earlier also used in a control unit, as the reference value was decided through the program itself. But here the sequence is basically controlled by adding a clock. The clock will either decide that if a sequence needs to be implemented after a given duration of time or not. So clock आपको कहाँ पे चाहिए होगी, जहाँ पे कुछ टाइम के बाद आपकी कोई ना कोई सीक्वेंस ऑफ ऑपरेशन को हमने इंप्लीमेंट करना है. or otherwise there can be another control where the sequence will be decided when one of the process has been completely finished, or it has completely or it has been completed. So how it will be decided? When the output value over here will become equal to the reference value for that sequence of operation, like for the pump, which is the first sequence. जब आपकी पंप के लिए इंस्ट्रक्शन जो प्रोग्राम में दी आपने वो आउटपुट पे कंप्लीट हो गई, इनपुट एंड आउटपुट बिकम इक्वल, and there was no error signal or different signal generated from the feedback coming from this side. Then the second sequence, that is the valve opening or closing, will be implemented. Okay, so कोई भी sequential control दो तरीके से काम कर सकता है. Either it can work according to the clock for which the timer has been set, or it can work through the program of instructions by completing each sequence one by one. First sequence completed and no feedback signal or feedback signal generated will make the input signal equal to the output signal. That means no error signal generated. At that time, second process will be implemented. Now, when this process is completed, then third process is implemented, and so on. Okay, so 1, 2, 3, 4, everything is going on in sequence. So this is the simple methodology followed for any sequential control, either to use a clock or to complete each and every sequence, then implement the second operation, complete one of sequence of operation and then implement the second sequence of operations. Suppose you wanted the pump and valve to work simultaneously, कि आपका pump और valve simultaneously काम करे, pump भी चलता रहे और valve भी चलता रहे. But जो हमने एक तरीके से इसको we have suggested that one way of doing is that completion of one signal will implement the second signal. उस केस में ये simultaneously काम करने की ऑप्शन नहीं होती, वहां पे आपको टाइमर जरूरी होता है. That means after the pump has started, the clock will start on clicking or it will start on counting the time. Okay, pump के जब 10 मिनट बाद हम चाहते हैं valve शुरू हो जाए, when 10 minutes have been clicked on the clock, then valve will automatically start. Pump is still running, but the valve has also simultaneously started. Okay, this is another way of doing the sequential control. So sequential control done through two tricks or two methods, that is by either clocking the process through the clock or through completion of one sequence and to then implement the second sequence of operations. Okay, so this was sequential control. Another type of controller which is used for sequential control is a PLC controller. Okay, now we have seen that there is a control unit, feedback control unit is there. It is having some sequence of operations which are going on. And now if we want to implement or if we want to go for a digital control system, which is a closed loop control system working on digital signals, and we want to implement some logic functions through sequencing functions, some timing and counting or arithmetic functions, there the use of PLC or programmable logic controller is there. ठीक है, तो हमने अब एक कंट्रोल यूनिट, एक्चुअल में अब कंट्रोल यूनिट और माइक्रो कंट्रोलर यूज करना है, जो कि आपका कोई भी डिजिटल फॉर्म में वो आपका क्लोज लूप कंट्रोल सिस्टम के साथ काम करेगा, एंड इट विल हैव इट्स ओन मेमोरी ऑल्सो एंड what do you call processing unit also, memory also, power supply also. So that will be called a PLC controller. So पता लगे आपको PLC controller का क्या काम है. You have seen that you can control any process through a controller which will have number of units, and the controller is working on the digital form of data. And if that digital form of data is used for implementation of some logical functions, and then you are controlling some process, there you will use a programmable logic controller. Okay, so a controller, so इसमें क्या क्या चीजें होगी? Controller used for a digital closed loop control system using, अब देखिए डिजिटल डाटा भी यूज करना है आपको और क्लोज लूप कंट्रोल सिस्टम यूज करना है टू कंट्रोल सम प्रोसेस. फर्दर व्हाट यू आर डूइंग इज okay, so a controller used for digital control of a closed loop control system having logical sequencing. So what is logical sequencing? That means it will be using logical gates. तो हमें यहाँ से पता लग गया कि अगर इसमें the word logical is used, that means it will be using some logical gates. Okay, to control, what to control? Either a sequence, either a timing, either a counting, or either a arithmetic control. तो अब हमने उसको narrow down कर लिया है. We have started with a control unit, then we learnt the digital control unit, and then digital closed loop control unit. Then a microcontroller is a good example of, जो आपका computers में use होता microcontroller, that is a good example of a digital control system used for controlling a process, है ना? That is a very simple example we have been using in each and every system. But before that, if we want to use a much simpler microcontroller which is working on logical gates, there the implementation of programmable logic controller is there. तो PLC भी एक type of microcontroller है जिसको आप use कर सकते हैं for simpler processes. So it is cheap, it is simple to use because it is working on simple logical gates. So you can reprogram that processor very easily to implement sequential functions again and again. So PLC की आपकी एप्लीकेशन कहाँ पे होगी? अगर आपने कोई सीक्वेंस कंट्रोल करनी है, अगर आपने कोई टाइमिंग कंट्रोल करनी है कि इतने टाइम के बाद ये चीज चल रहे, ये चीज बंद हो जाए, या आपने कुछ काउंट करना है. So if something is coming on the conveyor belt and you want to count कि कितने number of piece आपके उस conveyor belt से cross कर गए, so you can do the counting also. Or you want to do some simple mathematical calculations also, arithmetic calculations. There the use of PLC is there, है ना? Microcontroller को use करना, it is a little expensive and you can reprogram it also. So number of benefits are there, but PLC is a lot more easier to use for logical gates which are used for sequencing, timing and counting. It can be easily reprogrammed. ठीक है, तो इसके क्या क्या कंपोनेंट रहेंगे? PLC का एक प्रोसेसर रहेगा या कंट्रोलर जिसको कहते हैं, some memory for storing a small number of programs, sequential programs. इनपुट और आउटपुट मॉड्यूल होंगे एक तरफ, जैसे आपका माइक्रो प्रोसेसर में भी या मदरबोर्ड में होता है इनपुट पोर्ट्स, आउटपुट पोर्ट्स, इट विल हैव द सेम पोर्ट्स. चेसी जिसमें सारा कुछ इंटीग्रेटेड है, पावर सप्लाई इसको इंडिविजुअल देनी पड़ेगी, एंड अ सॉफ्टवेयर वेयर इट कैन बी रीप्रोग्राम्ड अगेन एंड अगेन. ओके,
Excuse me, sir.
ओके, ये हाँ जी, यस,
सर वो हमारा नेक्स्ट लेक्चर से स्टार्ट हो गया सर।
हो गया टाइम। ओह सॉरी
Yes,
सॉरी
sir.
सॉरी 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 सॉरी, चलिए ठीक है। सो आई होप यहाँ पीएलसी तक यू हैव अंडरस्टूड इट, देन वी विल मूव फर्दर इन द नेक्स्ट लेक्चर। ओके, थैंक यू वेरी मच।
यस सर,
Thank you,
थैंक
sir.
यू सर।